Good evening, ladies and gentlemen. This is Miss Hahn, your teacher speaking. Um, Today we did a light lab in class, remember? And we learned about light energy. And we used a mirror and we used a fishbowl, not really a fishbowl, but a glass with water in it. And we also we used more than one mirror also to see what would happen. And then you remember that cool thing I did with the laser light? Yeah. That's one of my favorite things to do, by the way, just because I think it's cool. So, anyway, so while we were doing that, one of the things we learned was not supposed to be a star. Light travels in what kind of line? Oh, I heard it. A straight line. Okay, that right there is a symbol in geometry for line. Okay. We also learned that it reflects. Light reflects. Okay, or what is that word? Right, bounces. Remember we talked? When it reflects, it's bouncing off so that you can see. Bounces off surfaces. So an example of that would be like visible light. Why do we see the color purple? Why do we see the color pink? Remember? Okay. Or when we have a mirror, remember? Oops, let me erase that. When we have a mirror, we're looking in the mirror, remember? So, see your smiling face when you're here. Oops, I didn't give you a nose. Okay. A reflection. The light is bouncing. Bouncing off the mirror so that you can see it. Okay? And then the other thing. Refraction. Good job. Oops, I spelled that wrong. It refracts. Or what was that? Bends. Good job. Or it bends. When passing through mediums. Now, what is a medium? Anybody remember what that is? Okay. Right. So when we were in the lab, we did this, we had this glass, right? And it had a pencil in it. We had our water in here, right? Oops, I forgot the blue. We had our water in here, right? And then we had a pencil. Then we had a pencil sticking in here, right? And remember, it looked broken. Okay. That's because that light is shining and it's refracting. So it's bending the light so that it looks like the pencil is broken. Okay. You also did your hand or your eyeball. So another thing you were supposed to look at. Remember that? You're supposed to look through the glass. Your partner was supposed to look through the glass and you're supposed to see what happened. Okay. I don't know if we had time for the microscope, but if you test it, when you look through a microscope, if you put the letter E right side up on the microscope slide, when you're looking through the microscope, the E actually looks upside down. So the light is being refracted in the microscope. Okay? So then we have visible light. And visible light is that part of the spectrum, right? Where we're going to see Roy, G, Biv. Anybody remember where that one comes from? Right, this is the color of the rainbow. So we have red, orange, yellow, green, blue, indigo, which is kind of a mixture of blue and violet, or blue and purple, and then we have violet. Okay, that's called our visible light. When all of these are together, when all of these are mixed together, this is white light. Okay, so what happens, all of these lights, so if it's white light, it's shining on you, right? Okay, I have a red shirt. I have a red shirt. I've got white light shining, right? Let's see if I can do this. I got red, yellow, green, red, orange, yellow, green, blue, dark purple, and purple. Alright, so what's happening? The light is shining, right? All that white light is shining, remember? Okay, so I've got red. Actually, let's go backwards. I got purple shining on it, right? Well, purple is going to go into that shirt. And then I have indigo shining on it. Indigo is going to go into that shirt. Then I have blue shining on it. Blue is going to be absorbed into that shirt. Okay? Now remember, this is all white light. White light is all these colors mixed together. Okay? So we're going to have blue going into that shirt. And then I'm going to have green going into that shirt. Okay? Then I'm going to have yellow being absorbed into that shirt. Then orange is going to be going into that shirt. Now, what happens with red though? Why do I see red? Because that's what's bouncing off of that shirt. So any red that's coming off, all of that white light and the red is bouncing off. So that's why I see the color red. Okay? That's why I see the color red. Because all of those colors are bouncing off of there. All that red is bouncing off. So I see red. All those other colors in white light are being absorbed into that shirt. Okay? So when I have a white shirt, all of these colors are bouncing off. Okay? So if I have a white shirt and all the colors are bouncing off, what does a black shirt do? Why do I get so hot and black? I wonder. So if white bounces off the colors, black absorbs the colors. So why do I get so hot? That's an interesting question. I wonder if anybody can tell me that in the morning. So, for our visible light, remember all these colors are white light, and white light is what we see, right? Okay, we don't see that breakup of colors. Ms. Hahn's going to try to show you. I don't know if it worked yet because I haven't done it in class, but we should be able to see white light being broken with a prism, okay? And I'll show you all that in class. So the reason that we see color, because we see color because that color of white light is being reflected and the other colors are being absorbed. Okay, so white equals all colors reflected, black equals all colors being absorbed. Okay? So, let me fix this so y'all can see the whole page. Oops, wrong way. Alright, light energy. Okay, so remember, light always travels in a straight line. Travels in waves in a straight line. Okay? It reflects or bounces back. It refracts or bends. We also have visible light, which is all 7 colors, right? 1, 2, 3, 4, 5, 6, 7. 7 colors all put together. The reason we see colors is because that color is the one being reflected off of the shirt. Okay? And then white, everything's reflected. Black, everything absorbed. So I wonder why we get so hot in black still. Interesting. So I hope y'all have a great evening, and I will see you on Monday. Talk to you later.